Lesson 2C, Further Expansion. In this section, we're going to expand more complicated expressions than we did in 2A by repeated use of the expansion rules that we learned earlier. First example, more complicated equation. Let's do A plus B and times that by C plus D plus E. Now you notice I have a binomial times a trinomial. And so with this type of equation, I'm going to have to do the distributive property twice. And what I'm going to do is I'm going to take this A and distribute to all the terms in the second polynomial. So we're going to start with A times C, which is just AC. And then I'm going to take the A and I'm going to times it by the second term, the D. And that's going to give me A times D. Plus, now let's distribute the A to the last term in the trinomial, and I get A times E, which is AE. Next, we're going to take the B and distribute to all the terms in the second trinomial. So we're going to start by taking B times C, and that's going to give us BC, so plus BC. Then I'm going to take the B and distribute to the second term in the second parentheses. So that's going to be B times D. So I'm going to add B times D. And finally, I'm going to take a positive B and times it by a positive E, which is going to give us plus BE. Now look closely. You'll notice that the first parentheses has two terms, A plus the B. And our second parentheses has three terms, A, a D, and an E. And look at our answer. Our answer has 6 terms, which is the same as 2 times 3. So this is another way for you to check and make sure you have all the terms and you've multiplied everything out correctly. You simply multiply how many terms in the first parentheses by how many terms in the second parentheses, and that equals how many terms you should get in your final answer. For our first example, our instructions are to expand and then simplify. So A, we have x plus 4 times x squared minus x plus 2. So we're going to do the distributive property. So we're going to start by taking our first term, which is x, and distribute to all the terms in the second parentheses. So we have x times an x squared, which should give us x cubed. Then we're going to take the x, times it by a negative x, which will give us a negative x squared. And finally, take that x and times it by 2 to get a positive 2x. Next, we're going to take the 4 and distribute to all terms in the second parentheses, starting with 4 times x squared, which is going to be a positive 4x squared. Now, I could write it over here, but to save myself a little work, I notice I already have an x squared term. So I'm going to write this x squared term right below it so I can line up my like terms, and it'll make me easier to simplify this expression. Next, we're going to take the 4, and we're going to times it by the negative x. And that gives us a negative 4x. So again, I'm going to write it right below its like term of 2x. And then we have a 4 times a 2, which is plus 8. I don't have any like terms to line that up with. And now we're just going to add all of our terms together. So x squared plus x cubed plus 0 is x cubed. Negative x squared plus 4x squared gives us a plus 3x squared. And a 2x minus a 4x is equal to negative 2x, and 0 plus 8 is just 8. So that would be my simplified, expanded form of the equation. Example B, I'm going to do the exact same thing. So in the first parentheses, I have a 3x. I'm going to times that by x squared to give me a 3x cubed. Then I'm going to take the 3x and times it by x to give us a positive 3x squared. And the 3x times a positive 5 will give us a positive 15x. Next, we're going to look at the second term in our first parentheses and distribute to everything in the second parentheses. So 1 times x squared is x squared. And again, we're lining up our like terms. And then I'm going to take 1 times a positive x, which will give me a plus 1x or a plus x. And 1 times 5, which gives me a plus 5. Adding up our like terms, which I conveniently lined up, I get 3x cubed plus 4x squared plus 16x plus 5 as my simplified answer. So in example C, we're going to do the same thing. I'm going to take that 5x and distribute to our first term in the second parentheses. 5x times x squared gives us a 5x cubed. Then I'm going to take the 5x and times it by x to give us a plus 5x squared. And then the 5x times by 4 gives us a positive 20x. Then I'm going to do the same thing for the second term in the first parentheses. I'm going to take a negative 2 this time and times it by x squared. That gives us a negative 2x squared. Negative 2 times x is a negative 2x. And the negative 2 times 4 gives us a negative 8. Lining up our like terms gives us a 5x cubed plus a 3x squared plus an 18x minus 8. In our second example, our instructions are the same. We're going to expand and simplify. But what's going to be different this time, instead of multiplying 2 polynomials together, we're going to multiply 3. So in example 1, we got x times x minus 5 times x plus 3. And all you do is just take this step by step. So I'm going to start by taking the x and times it by the x minus 5 using our distributive property. So that gives me an x squared. And when I take x times a negative 5, that's minus 5x. And now I have a new binomial that I'm going to times by the binomial 3 plus x. And I'm going to do this just like we did in one of our first examples. And we're going to use the full method. The first, outer, inner, last terms multiplied together. So for our first terms multiplied together, x squared times x, that should equal x cubed. And then we're going to do our outer terms, which is x squared times 3, and that'll give us a plus 3x squared. Our inner terms is a negative 5x times x, which is a negative 5x squared, and our last terms, a negative 5x times 3, which is a negative 15x. And then I'm going to combine any like terms. So I notice I have a 3x squared and a negative 5x squared. These are like terms, so I need to make sure I multiply these together before I write my simplified answer. So let's see, that gives us an x cubed minus a 2x squared minus a 15x. And this is your expanded simplified answer. For example B, we're going to use the distributive property and we're going to distribute this negative 2x to the binomial 3 minus x squared. So a negative 2x times 3 is going to give me a negative 6x, and a negative 2x times a negative 4x, well, that's plus 8x squared. Now I have a binomial negative 6x plus 8x squared times the binomial x plus 2. So I'm going to use the full method to simplify this. So we're going to start by multiplying our first terms together, and that'll be a negative 6x squared. And then our outer terms together, which is going to give us a negative 12x. And then our inner terms together, which is a plus 8x cubed. And then our last terms together, which is a plus 16x squared. So as always, I look and see if I have any like terms. Well, yes, I have 2 like terms. I got a negative 6x squared and a positive 16x squared. So those are my like terms. I need to combine those together. And I also want to rewrite this so I have my highest power written first. So let's first reorganize all our terms here, starting with that 8x cubed. So I got 8x cubed, and now let's do our square terms. So I have a negative 6x squared plus a 16x squared minus a 12x. And then let's combine those like terms. So that's 8x cubed plus a 10x squared minus a 12x to give us our final simplified answer. In example C, we're going to see what happens when you try to multiply three binomials together. So we're going to do the same thing, but this time we're going to start by our full method. So I'm going to multiply 3x times x to give us a 3x squared. Then I'm going to multiply my outer terms together. So a 3x times a 2 is a plus 6x. My inner terms together, which will give us a plus 1x or plus x. And our last terms together, which is just plus 2. And I still have that x plus 3 that I haven't worked with yet. But before I multiply out, let's combine any like terms that we have. So let's rewrite this first parentheses as 3x squared plus 7x plus 2. It just less terms makes it less work I have to do later in multiplying out. Now we're going to do our distributive property, and I'm going to distribute that binomial to the trinomial because it's easier to only distribute twice than 3 times. So I'm going to take that x and I'm going to distribute to every term in the first parentheses. So 3x squared times x gives us a 3x cubed. And then I want to take that x and times it by the 7x to get plus 7x squared. And x times 2 will give us a plus 2x. Then I'm going to use the distributive property again, but this time with the 3. And I'm going to distribute it to all the terms in the first parentheses. So I'm going to start with 3 times a 3x squared. And that gives us a 9x squared. And I'm going to write it underneath my like term. So I'm going to place it over here. And then I have that 3x times a 7x gives us a positive 21x. And then 3 times 2, which gives us a plus 6. Combining our like terms, we end up with our final answer of 3x cubed plus 16x squared plus 23x plus 6. Our third example, the instructions are to determine how many terms you would attain by expanding these following. So notice that in my first expression, I have 2 terms. And I'm timesing that by a binomial of 2 terms. So my final answer should have 2 times 2 terms, or 4 terms. And this is when I multiply it all out before I add any like terms. But as you can see from x plus y times z plus w, I'm not going to have any like terms. So my answer to this problem would be the expansion would have 4 terms. Example B, I'm going to take 3 binomials and multiply them together. So let's figure out how many terms I would have in that case. So in this example, I got m plus n times p plus q times r plus s. So again, there's not going to be any like terms to combine. So in my first polynomial, I have 2 terms, or a binomial. And then I have 2 terms in this second parentheses. And the third parentheses also has 2 terms. So I know my answer should have 2 times 2 times 2 terms, or 8 terms. So I would say the expansion would have 8 terms.